Hey guys, welcome to another video. So today we continue on with the nice question series. Today's question comes from the Extension 1 syllabus. In fact, it comes from the HSC 2022. It's a projectile motions question. It's 4 marks. Love it. It's a really nice question. It's one of those questions where there is no real numbers in the question, and for some reason you have to prove something with a number. It's pretty cool. So before I dive in, as always, please, if you haven't already done so, subscribe to the channel, like the video, and tell your friends. So let's dive. Now, HSC 2022, it's a nice one, where, the classic, and I say this to my classes all the time, whenever you get a question in mathematics, especially in projectile motion, where there really is no numbers, ironically, without numbers makes the questions harder, right? When you have numbers and you get to sub stuff in, it's actually relatively straightforward. For this question here, there really isn't many numbers around, but all of a sudden at the very end, right, you have to prove something like with 37%. I mean, where does that come from? It's a great question. So let's slowly peel through this question, extract out the key components. So video game designer wants to include an obstacle in the game. They're developing the player will reach one side of a pit and must shoot a projectile to hit the target on the other. So they're basically trying to fire off a projectile from this point, right? And trying to hit a target. Now, what's special about the target? However, the instant the player shoots, the target begins to move away. So guys, this is the projectile and this is the target, and it moves as you're sort of shooting the projectile. So basically, as you're shooting the projectile, the target sort of moves away from you as well, okay? So the target begins to move at a constant speed that is half the initial speed of the projectile shot by the player. Okay, shown in diagram below. Okay. The initial distance between the player and the target is D. Okay, so the pit there is D. Good. Initial projectile is 2u, launched at theta. Okay, the acceleration is gravity. And launch is the only thing I can change. So all I can change is theta, right? Okay. Taking the position of the player when the projectile is launched at as the origin. Okay, position of the projectile on target. Okay, so this is the projectile itself, right? And this is the target, right? So just to be clear, target's moving away, projectile was projected, and I'm assuming there's a collision of some sort, right? Show that. Now this is what I need to prove. Show that for the player to have a chance of hitting the target, D must be less than 70% of the maximum. Okay, D must be less than 37% maximum possible range of projectile. Okay, hitting the target means collision, right? Now, it is worth noting that when you hit the target for this question, right, hitting target equals to collision. And mathematically, what that means is, right, X and Y displacement or position at same T, right? So what I'm going to do for both the blue and the green, I'm going to set the X values the same and the Y values the same. And then basically it implies that the time is the same for both, and we'll go from there, right? We'll see what comes out of that. So now that 37%, if I was to do this question in HC, that's worrying because there's nothing in here that's giving me any numbers. Where does a specific number like 37% come from? Well, let's just, now, if this was in HSC, I would actually advise my students, let's just dive in, right? Dive in and see where it takes you, right? So I'm going to set the X displacement, right? So 2ut cos theta, right? Set this guy equal to the X displacement for the target, right? And, I don't really know where this is going. So I'm going to, at the same time, set the Y displacement now. 2ut sine, right? 2ut sine theta minus is a half t, a half. So G on 2t squared. So that equal to 0, right? 0 because the target is on the plane, right? All right. Now, with that in mind, let's see if I can simplify the algebra. Now, in the thing I want to prove, doesn't really talk about time. So I feel like, right, what I'm going to do is maybe, I don't know, make t the subject and sub it in, maybe. Let's have another quick look. I've got to do something with max range as well. But at this point, feels like I've got to put them together somehow, right? So what I'm going to do, let's see. Yep, let's make t the subject here. Right, so I'm going to factorize t out to u cos theta and minus u equals to d. Right, maybe make t the subject there. Yeah, I don't have time in this, right? So I want to get rid of time. So 2u cos theta minus u. And then I'm going to pop this guy. Potentially feels like, should I pop that into the other one? Feels like it, right? Feels like something I should do. Yeah, why not? Do there and there, right? And hopefully I get an expression I can play with, right? So let's see. I get 2u sine here multiplied by d over 2u cos theta minus u. Ooh, this looks nasty, guys. This looks really nasty. So minus g on 2. Now, let me just check that the algebra is right. Sub that into 3. Yeah, feels right. Oh, you know what I should have done? I should have been smart about it. Maybe I'll do it now, right? No. I can still do it. Yeah, let's still do it. I'll show you what I should have basically crossed out the t's, right? Like, so factorized t out and crossed it out first. You know, maybe I'll do that. Yeah, we do. Sorry about that. Just makes it easier, right? So, firstly, at this line over here, right? So before you sub t in, a smart thing to do, factorize t out. 2u sine theta minus gt on 2, right? Equals 0, because this t here, I don't need it, right? Because t is 0, okay? Don't care about it. I care about the other guy. So then instead of subbing in to there, all I really need to sub really is into this guy. That's better, smarter. Let's do that. Minus g on 2 times d. That's better. A bit cleaner. Still very messy. Here we have it. Now, what am I trying to do? I'm trying to make an expression for d, right? Yeah, because basically it's telling me, can I please show that d is less than 37% of maximum range, right? So make d the subject. So I've got 2u sine theta minus gd, also equals to, bring this guy over the fence, 2 times 2u cos theta minus u. Right. Rearrange that, make d the subject, therefore d equals to, so times this guy up, divide the g down, I believe, right? So it becomes like, let's see, 4u, is that right? 4u, yep, cool. 4u sine theta, bracket 2u, oh, actually I can take out, looks like I can take out u from both of these, right? So let's do that first. So 4u squared then 2 cos theta minus 1 all over g. Yeah, that looks about right. Now, if that's my d, right, I'm just going to quickly pause there and then go, okay, they want me to prove that d equals to 37% of maximum range. Somewhere in here, there might be a 37% and a maximum range. So why don't I try to find maximum range? Now, I know to find any range, right? Yeah, within a projectile, I set the y value equals 0, and then I find the total time of flight and sub the total time of flight into the x value, right? To find the x displacement, to find range. So what I'm going to do, I'll do exactly that. So for this one here, set the y value upstairs there. Yeah, in fact, let me do it from scratch, right? So saying y equals 0, go 2u t sine theta minus, was it g on 2 t squared, set that equals 0. Once again, factorize t out, right? 2u sine theta minus at gt on 2. Yep. So obviously t is 0, right? Don't want that one. And then if I made t the subject here, bring it over times 2 divided by 2. So before u sine theta on g, okay? That's total time of flight. Guys, I'm running out of space. Oh, that's because I started so low. So what I'm going to do, what we do now? Bring this up. Okay. All right, that's total time of flight. So I want to sub that into the x value where therefore x equals 2. What was the x? 2ut cos. So I'll just go 2u cos. Now sub this t in. And g. Now what's that give me? This is my range, right? So it'd be like, how about I factor? So I'll make double angles, right? So 2 sine cos. So it'd be like 4u squared sine double angle on g. Yeah. Now, if this is my range, right, and my range depends on a sine to theta, right? I know that the maximum value this guy can take, right, is 1, right? The maximum value that guy can take is 1. So therefore, right, therefore, maximum range, right? Everything else is constant. I can't change u, and gravity doesn't change. The maximum range has to be 4u squared on g. Does that make sense? When the pink part is 1. Now, why is that super important? And this is key, right? I've now got max range, and you can sort of see, right? Max range, this guy here is this guy here, right? That's super, super, super important. Because if that's the max range, and I've got max range here, then if I can demonstrate that this part here, right, is 37%, right? If I can show 37% here, right? If I can show that the green part is 37%, I've demonstrated that the distance has to be 37% of the max range, right? So now there were 2 parts of the puzzle, max range 30%. I've got the max range now. Now the green part 30%, right? 37%. So let's copy this slide over to the next one. Let me remove everything. Give me a clean sort of slate to work with to prove the 37%. So, but I do need that expression here, right? So I'll start off here. Perfect. Yeah. Now, this is where from numbers, so from a question without numbers, we're going to have to demonstrate 37% somehow, right? So this is what I'm going to do. Right? So maybe I'll go let the function equal to the green part only. Now, firstly, I need to demonstrate that I'm going to get a maximum value from that, right? I need a maximum value from that to be 37%. That's what I want, because then it shows me that, because the question goes, D must be less than that, right? So I want the green part to be maximum 37%. So let's go there. So now, if I define this guy, guys, if I expanded that, that's like 2 sine, that's double angle of sine minus 1, right? That's my function that I'm defining now. I'm going to need to find the maximum value of that by using calculus maximum minimum, right? So let's differentiate that. So when I differentiate that, I get, what's that, 2 cos 2 theta. So that should be not 1, but sine theta, right? Sine theta, that's better. Then minus cos theta, I think that's right. No negatives, right? Is that fine? Perfect. Right, nothing fancy there. Guys, I need to solve, right? So if this is my first derivative, yeah, I always like to put a box around my first derivative because I'm going to use it for max min, right? I'm going to test for max min. So I'm going to be differentiating that guy. So I'm going to be transforming it a bit here to solve it. I don't want to sort of lose sight of what my first derivative is. How do I solve this, guys? Maybe this guy here, right? That is, I'm going to turn that using double angles to be the one with cos, right? So 2 cos squared theta minus 1 minus cos theta was 0. Gives me like a quadratic in terms of cos. So if you solve this, by the way, for those that are looking at the internet to find the solutions for this, I found their solution for doing maximum minima here quite complicated, right? I'm just going to do it old school, right? So solve that quadratic where cos theta using the quadratic formula, minus minus 1 plus minus square root on 2 times 4. That's like minus 1 squared minus 4, 4, 2. I think that's 33. So cos theta equals 1 plus minus root 33 on 8. Now, guys, whenever we're doing projectile motion, right, it is important for you to sort of go, well, theta has to be between 0 degrees and 90 degrees, right? It can't be like 180, and it can't be like anything, well, it can't be bigger than 90, right? And it can't be negative. So why am I telling that? Because for the plus minus, for this guy, I don't need the minus, because if it's minus, it's negative, and cos negative is either in the second or the fourth quadrant, right? So second or the third quadrant, I don't want that. So all I care about is therefore cos theta, 1 plus root 33 on 8, right? That's the one I want to test. Now, I need to demonstrate that that is maximum by using the second derivative, right? So let me move this over slightly to the right, just so I can have a bit of vertical space. Yeah, cool. So guys, find the second root. So this one here, test for max min, right? Yeah, where you go second derivative of theta. Now, what was the first derivative? 2 cos 2 theta. So that becomes negative 4 sine 2 theta. I think it was a minus cos, right? Minus cos, so it becomes derivative of cos is plus sine theta. Is that right? Yeah, just quickly check that. Yep. And now I need to sub in. Now, before I do that, maybe find the angle. So if you shift cos that guy on your calculator, just to get the angle, right? Yeah. Yeah, I'll do it as well. I think you get 32.5 blah 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 degrees, right? Now you can deal with this in radians. I'm just going to deal with degrees, right? If you put this angle now into here, so right, 32.5 degrees, right, equals to minus 4 sine 2 times 32.5 degrees plus sine 32.5 degrees. Now, yeah, I'm just leaving it. Normally I'll go to radians, but for this one, because everything is in theta, sine theta and stuff, you can leave it. You actually get like negative 3.089, blah, blah, blah. To be honest, don't care about the magnitude, just care about the signage. Because it's negative, less than 0, therefore, second derivative, less than 0, sad face, maximum, right? Max when theta equals to 32.5 degrees, right? That's good. So basically, guys, this is saying when theta equals to 32.5 degrees, I'm going to get a maximum. Now, the final piece of the puzzle is if I plug this 32.5 degrees, if I plug this guy into the function here, I'm hoping it gives me 37%. So let's try that, right? So therefore, right, conclude max value of sine, what was it? Sine theta. Is that the one I want? Yep. Sine theta 2 cos theta minus 1, right? Equals to, so on your calculator, if you punched in sine 32.5 degrees, 2 cos 32.5 degrees minus 1, yeah, guys, can you do it for me? Pretty sure you get 37%. Yeah, make sure that happens. Now, once you do that, you've done it, right? You've put two pieces of the puzzle. You said the blue part in this formula here, right? The blue part is max range. The green part, the maximum is 37%. Therefore, right? Therefore, let's answer the question, right? Therefore, D must be less than 37%. of max range? Yeah. What a question. I love it. Guys, this question was so cool because it started with no numbers. Well, really, no real numbers. Ended up with 37% of max range. HSC, you've done it again. Guys, if you like that video, subscribe to the channel, tell your friends, and like the video. I'll see you at the next one.